Hello everyone, my name is Yekeh, and today I'm presenting on the traditional metal and ancient and modern stromatolites. The importance of traditional metals is that it's required for all forms of life, and stromatolites are fossilized layers that are usually made by the tapping of microbes, and stromatolites can usually show the water chemistry of that time. Stromatolites only grows in carbonated environments. Now, stromatolites are related to transitional metals because it can help in interpreting the ancient ocean chemistry of that time as well. Today, the two stromatolites we're looking at are the Bahamas and the Allentown. The Bahamas are considered our modern stromatolites, and the Allentowns are considered our ancient. The Allentown is approximately 4.2 million years old and is much older than the Bahamas stromatolites. In order for us to test each substance, we had to ground each one of them in a powdery substance, as you can see here. We used a mortar and pestle to ground each substance. Each substance was grounded individually, and we took multiple layers from each substance. Once we crushed it, we did an acid digestion test for each one. We used HNO3 and HCl for our acid digestion test. We let the acid sit for 72 hours. We had about 22 to 25 substance. We did multiple layers and we did multiple duplicates just to test and to make sure we had the right amount. After the 72 hours was done, we used HPLC water in order for us to dilute it down. After that, we used an ICP-OES machine. The ICP-OES stands for inductivity, coupled plasma optical emission spectrometry. Once we did the ICP-OES, we did two tests for it. The first test, we did not dilute the Allentown as much as we diluted the Bahamas. The Bahamas was diluted by 1 to 10, but the Allentown was not. For the second run, we diluted both Allentown and Bahamas to 1 to 1,000, and that helped with our analyzing the chemical compound of both rocks. Now, we split the chemicals we're looking for in two major groups. The two major groups are trace and majors. Our trace groups, we usually looking for iron, we're looking for copper, zinc, nickel, and many more other chemicals that you can see here. And for our major, we're looking for sodium, magnesium, phosphate, and many much more. But when we ran the ICP-OES and we got a result, we found out for the first one that our majors was oversaturated, so it couldn't read the machine. The machine couldn't read it. The reason why we diluted is because ICP-OES can only handle 5% of a strong acid. If it's more than 5%, it starts giving error. For our second run, our trace and majors both came up, but for our sodium and calcium, it shows that it was still oversaturated, so it couldn't get us a proper reading for that. So we was only able to get a 2-point curve instead of a 5-point curve that we was able to get for the rest. So for our graphs, we label our graphs from oldest to newest. So the oldest ones is our Allentown. So the Allentown comes from the bottom to the top. We did the same thing for our major. We put our Allentown on the bottom and our Bahamas on the top. We did this in order to show the difference of how the chemical increase or decrease over the period of time. Once that was done, we showed that the elements we needed to prove that the transitional metals that are required for life are in both rocks. Later, we did a 50-50 ratio. Our 50-50 ratio shows the magnesium and calcium ratio, and you can see that the Bahamas had a low versus the Allentown, which is really high. Since the ocean changes over time, that can also have effects on the amount of magnesium and calcium we found in the Bahamas versus the Allentown. Remember, the Allentown is higher in age compared to the Bahamas samples. Here we did a MR and SR scale for both Bahamas and Allentown, and the Bahamas are on the bottom as well as compared to the Allentown. Here we show the concentration level of each that was in the run 1. And some of the samples showed up and some of the samples did not. Also, for ICP-OES, the settings you have it on determine what wavelengths the machine can read. So we had 2 different settings in order to read some of our chemicals. Lastly, we can just prove from our data that the allantoin contain primary chemical signatures that we need to prove that it does have transitional metals that are connected to life. So based on our data, we can say both allantoin and Bahamas contain that, and I'm satisfied with the result that it was given. I just want to thank the RAU and Dr. Gates and Ashley Murphy and the Natural Science Foundation for giving me the opportunity.